Dear students, in electrostatics, the maximum times the word used is the electric field. Today I am going to talk about electric field, expression for electric field. To explain the electric field, I am going to use a graph paper. On this graph sheet, let us consider 2 points, that is a point O, another is a point P. At point O, let us place a charge Q, and at the point P, let us place a charge Q. Here at origin, the capital Q, at the point P, the small q charge is placed. Now join O and P. So we have joined O and P. So OP, nothing but it is a vector OP, that is equals to vector R. The charge Q placed at the origin and the charge Q placed at the point P, both are the point charges. And second point, vector OP equals to vector R. Now the r cap is nothing but unit vector in the direction of vector OP, that is r cap. R cap is given by vector R divided by magnitude of vector R. Here one more thing I need to tell you, that both the charges are placed in vacuum, so that there is no other interfering medium is present between both the charges. Now both the charges are similar nature, therefore there is a Coulombic force is present between both the charges, and due to this both the charges exert a force on each other and there is a repulsion. Now what are the names of the charge Q, capital Q and the small q? We have to give some name to them. The charge placed at the origin, that is a capital Q, is called source charge, and the charge placed at the point P, that is a small q, is called test charge. So there are the two charges are there, source charge and the test charge. Electric field is the story of the source charge. In the electric field, while defining the electric field, we are talking all about capital Q. We are talking about all source charge, how strong the source charge, that story is nothing but electric field. Now how much the value of the test charge? The value of the test charge is very small, it is near about 0. So we say the magnitude of the test charge is tending to 0. Since both the charges are placed at a distance r from each other, so the physical distance, that is the magnitude of vector r, so that is equals to small r. Now the electrostatic force between both the charges, since the charges are placed at a distance r, so the denotation is like f of r, that is the distance between both the charges. F is the force, electrostatic force present between both the charges, is given by Coulomb's law, Coulomb's law of electrostatics, that is f of r equals to 1 upon 4 pi epsilon naught and q multiplied by capital Q upon r square and multiplied by unit vector in the direction of vector OP, and let us call it as the equation number 1. Now let us assume that you are moving the test charge. You are moving the test charge on the spherical shape, that is a 3-dimensional. Here on the screen only I have shown you the 2-dimensional, but let us assume that the test charge is moving on the 3-dimensional shape, 3-dimensional spherical body. Then the force exerted by the source charge will not change, and that effect developed by the source charge on the test charge is nothing but called as the electric field. And now suppose we remove the test charge and we keep only the source charge. So just remove the test charge. Now we have removed the test charge. Then also the effect of the source charge is not nullified. It is there. It is realized only when the test charge is present. But the effect of the source charge is always present. Whether the test charge is present or not, the effect of the source charge is always present. And it is equal in all direction. Unless and until you change the R value, the value of the electric field will not change. The magnitude of electric field will not change. That means the electric field is a function of distance. It is a function of R. So it is a vector R and it is a capital Q is the magnitude of the source charge. Now electric field, the value of the electric field is a function of R. It can be denoted as a E of R is equals to 1 upon 4 pi epsilon naught. Why we take an epsilon naught? Because we already made a supposition that the charges are placed in the vacuum. And if the magnitude of the charge increases, the value of the electric field also increases. And so Q upon, and it is a function of R. As the distance increases, the effect of the electric field decreases. So it is upon R square. And the value of electric field in a particular direction can be calculated with the help of multiplying it the unit vector R in the direction of vector OP. This is the point O and it is a point P. So it is a vector OP. And let us call it as the equation number 2. What was the equation number 1? We had the equation number 1, f of R equals to 1 upon 4 pi epsilon naught Q multiplied by Q upon R square multiplied by this one. It was the equation number 1. So we have the two equations, equation 1 and 2. With the help of equation 1 and 2, we can define what exactly the electric field is. Now, equation number 1 can be written as f of R equals to 1 upon 4 pi epsilon naught Q upon R square multiplied by R cap and writing small q outside. Now this much part becomes a equation number 2. Therefore, the equation 1, here f of R, here is a bracket and here is a q. Now what we have to write in the bracket, because 1 upon 4 pi epsilon naught Q upon R square multiplied by unit vector R, that is nothing but this much, and this is nothing but E of R. Therefore in the bracket we can write E of R implies f of R equals to Q into E of R, implies E of R equals to f of R divided by Q. But what is the value of the Q? We have assumed the value of the Q is very small, and value of the Q we have assumed that almost equal to 0, tending to 0. Therefore, limit Q tending to 0. E of R can be defined as limit Q tending to 0, f of R upon Q. It is not 0, it is tending to 0, it is near about 0. So that the presence of the charge, presence of the test charge does not influence the field developed by the source charge. That is the value of the Q, small q, the test charge. The magnitude of the test charge is Q tending to 0. One more thing, the unit of f of R is nothing but force. Force is nothing but Newton, and this is the charge. Charge is nothing but Coulomb. Therefore, the SI unit of electric field is nothing but Newton per Coulomb. So from this equation, we even get the SI unit of electric field. One more thing, that we have the equation, that is the f of R. F of R equals to Q into E of R. And suppose we make a supposition here, Q equals to 1. When you make the Q equals to 1, what will happen? What will happen? F of R equals to E of R. That means electric field is nothing but a kind of force, a kind of force. When it is a kind of force, but under what condition? If Q is equal to 1. If Q is equal to 1. Thus, we can define the electric field by making Q is equal to 1. So, what is the definition of electric field? Let us see now. Electric field definition is developed from this equation by putting Q is equal to 1. So, what is the definition of electric field? Let us see now. So, definition of electric field. The electric field due to a charge Q at a given point. What is the given point? We had the point P. We had the point P like this, like this. Here was the charge Q was placed, and the given point was the point P. So, given point in a given space. What are those space? We consider it is a three-dimensional space. Three-dimensional spherical space may be defined as a force. What was the force? Force nothing but F of R. Force that a unit positive charge. We had taken Q equals to 1. Q equals to 1 would experience E placed at that point. Placed at that point means placed at the point P. So that is F of R equals to Q into E of R, and we have taken Q equals to 1. Therefore, F of R equals to E of R. This is implies the definition of ER is nothing but E of R is nothing but F of R. F of R nothing but a force. So electric field is nothing but a kind of force that is developed by the source charge, and that is existing at the point P. The point P is the given point. So this is what the definition of electric field, and this is the concept of electric field. So this is what all about the electric field. And electric field is depend upon the two factors. One is the value of the given source charge, another is the distance r. If you do not change the value of the source charge, then the electric field is a function of distance from the given source charge. That's all for this episode, and I hope you got through the concept of electric field. And before saying goodbye to you, I request you that share the video with your friends, so that what happens, the needy students, the students who want to clear their concept will go through the video, and all my hard work will be useful to some needy students. So let's say goodbye to you. Wish you good luck. All the best till next video. And don't forget to subscribe, share, and like the videos. Bye bye. See you.